Welcome to Pomodoro Joe for Tuesday, July 18th, 2023. Today we're doing LeetCode problem 146, LRU Cache. This is a medium problem. Design a data structure that follows the constraints of a least recently used LRU cache. Implement the LRU Cache class. LRU Cache int capacity initializes the LRU cache with a positive size capacity. Int get int key returns the value of key if the key exists, otherwise it returns -1. Void put int key int value. Update the value of the key if the key exists, otherwise add the key value pair to the cache. If the number of keys exceeds capacity from this operation, evict the least recently used key. The functions get and put must each run in O of 1 average time complexity. And then they have an example here. All right, so this would be pretty straightforward if we didn't have this last constraint that it has to run in O of 1 time complexity. All right, but given that constraint, we'll do what we can. Now, I've run across this problem in interviews before, so this is a good one to pay attention to. There are a couple different ways you could approach this, and I think the way they wanted me to approach it in the interview was to use a linked list. Now, I can show you how to do the linked list solution, but it's way more complicated than this other solution that I will show you. So the other solution I'll show you involves a data structure we don't normally use that often, so it's a little bit tricky, but we'll go over that in just a second. So first, this O of 1 average time, what does this mean? So this basically means you need a constant time operation. So if you find yourself writing something that uses a for loop or a while loop where you're iterating through a bunch of elements, that is not going to be an O of 1 time. That's going to depend on the number of elements that you have. So that would be an O of n time or worse. So O of 1 time means it's just a simple operation. Like in a standard dictionary, if you put some value into that dictionary, that'll be an O of 1 time. If you get a key value pair out of that dictionary, that's also an O of 1 time. So we could use a dictionary here, but the tricky part with the dictionary is keeping our capacity. So this is telling us we need to evict certain elements if we're over some capacity. And we need to keep track of which element to evict. And in this case, it will be the least recently used. So essentially, we have to keep track of the order of things that were used so that we can find the least recently used one, the one at the bottom of our list, and we can evict that one. Now, if we kept an array of our values, we could keep reordering the array, but reordering the array is not going to be an O of 1 operation. If you take an element out of the array and move it from the front of the array to the end of the array, you have to reorder all of the other elements in that array. So that's an O of n operation. So to keep this an O of 1 operation, we'll use a data structure called an ordered dictionary. Now this is something we don't use a lot, so I'll actually pull up the documentation here really quick. So this is in the collections library of Python, and it's here, ordered dictionary. So the ordered dictionary is a dictionary subclass that remembers the order the entries were added to the dictionary. So this is exactly what we want. So we have a couple additional operations that we can use. We have a pop item, which will either pop the last item or the first item, and it defaults to the last item. We also have move to end. So this takes a key and it will either move it to the last element in our order or the first element in our order, depending on this value here. So these are going to be key to us keeping our solution within the O of 1 runtime constraint. All right, so let's come back to here. So in the init, at this point, we just need to keep track of our capacity and we need to create some place to hold on to our storage. So we'll have a self.capacity equals capacity. So we're just going to hold on to this capacity. So this object, that's the self object, will just hold on to this capacity so we don't lose it. We also need some storage. So for us, our storage is going to be this ordered dictionary. So we have to use a constructor for ordered dictionary to create our storage. All right, so in our get will just be a key value lookup, standard dictionary type lookup. So first we'll just check if the key is in our dictionary, so our self.storage. Well, then we can return the value for this key. All right, that's pretty straightforward, but there's a little bit more we have to do to this. So the other thing we need to do is, because we've used this key, so this is our LRU part. So because we used the key, we actually have to rearrange its ordering. All right, and because this is an LRU and we used this key, it is no longer in the same ordering it used to be. We used this key, so we have to move this to the front of our list here. So in that case, we move it to the front of our storage. So self.storage. That was move to, let's take a look. I think it's move to end. Yeah, move to end, key, and our last. So we'll move this to the end with our key, but we want to move it to the front actually. So we're moving it to the end with a false, saying that we're going to move it to the front of our list. So essentially our ordered dictionary is keeping track of the order in which we're entering values into our key value pairs. So you can imagine that internally this storage, this ordered dictionary, has some list. It's a list of elements that are used. And every time you put an element into that list, it's going to go at the front of the list. And it's going to push all the other elements down in the list toward the end of the list. Now, as soon as we access an element again, we want to move that to the front of the list so that it is considered recently used. And then when we have to evict something from our cache, it's going to be from the end of the list. So we'll pop something out of the end of the list. That'll be the least recently used item. So we have to reorder here. Because we've accessed this item, we want to put it at the front of the list. All right, what else do we have to do here? Well, if we don't have the key in our dictionary, then we have to return -1. And I didn't set the Pomodoro timer. What? All right, let's get that started. Okay, so we've taken care of our init, we're storing the capacity, and we've created an ordered dictionary for our storage. Then in the get, if we've got this key, we're going to move this key value pair to the front of our list, and we'll just return the value for that key. If we don't actually have this key, then we return -1. All right, now in put. So we're putting a new key value pair into our dictionary. If this key is already there, there's not really much to do, so we'll just check. If the key is in our dictionary, well, in this case, it's very similar to our get case. We'll want to move that to the front of the list because we've just used this key for some operation. And then we'll just set the value. So the storage for this key becomes this new value. And we can actually just return. All right, now if the key is not in our dictionary, this is a new key to our dictionary. Now it could be that we have space and we can just add this key value pair, or it could be that we are at our storage capacity and we have to kick something out. So let's check that first. The length of our storage this is greater than or equal to our capacity. This means that we are at capacity. We can't just add a new key. We have to kick something out first. So let's just do that. Let's see, self.storage. I believe it was pop item. And we are just going to be popping at the end, which I think is the default, but let's double check here. Pop item last is equal to true. All right, so we're popping out the least recently used item. It's at the end of our list. All right, otherwise we just add this new element. So we basically do the same thing we did here. I guess we do it in the opposite order. So we'll just add this element. And we do move it to the end, although, or I should say the beginning, although I don't know if this is strictly necessary. I think because we're creating a new key value pair, this should already be at the start, but let's not take any chances. So let's go ahead and do this. All right, and this I think should do it. So in our init, we create our storage and we have some capacity. If we do a get, we just look for that key in our storage. If we've got it, we can just move it to the front and return that value. Otherwise, we return -1. Now, if we do a put, if we already got this key, all we have to do is change its value and move it to the front of the list. So that's what we do here. If we don't have this key, first we have to check if we have capacity. If we don't have capacity, we've got to pop an item, and we'll pop the least recently used item. So that's this pop item here. If we're not at capacity or we just created enough capacity, well, then we can just go ahead and store this key value pair, and then we'll move it to the end, or in this case, the beginning, because we're passing false, just to make sure it's at the beginning of our list. This might not be necessary, but I'm going to do it here anyway. We can try it without it and see what happens. All right, let's try this. Okay, so this works. Let's submit this and see how we do. And we pass. And it looks like we do okay. We do better than okay. We beat 95% for runtime and 86% for memory. Whoa, that is way better than I expected. Let's jump back and just see if we need to do this. I'm kind of curious. All right, let's get rid of this and see if we still work. No, we don't. So we actually do need to move that to the front of the list. That's good to know. Cool. All right, and because we used this internal structure, this ordered dictionary, we were able to save a ton of code and a ton of time in writing this code. And we actually performed very well. So this one, I would say, is the way to go. Use this ordered dictionary if you can. Now, if they ask you to use a linked list, that's where it gets super tricky. That kind of takes this medium problem and makes it a hard problem. I am not going to show you the linked list solution. The linked list solution involves, instead of using this ordered dictionary, you can use a standard dictionary, but you have to create your own linked list class. It'll be a doubly linked list so that it will have links going forward and backward. You will store the nodes of your elements in a dictionary. So basically you do a key value lookup with the key being the key passed in, but the value being a node, and that node will be a node in your linked list, your doubly linked list. Then from there you can grab the element, return it, or you can remove the element, you can move it around in your linked list, put it at the head of the list. So basically you can do all these same things just in a linked list fashion. And I am not going to bother going through it because it's a lot of work. All right, if you really want to see the linked list solution, leave a comment below. I will check it out, and if you really, really want to see it, I will do a video on the linked list solution to this problem. All right, I'm kind of losing my voice, so I think that is it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.